It's another TentCast! Scale! Tonight I'm going to talk about scale. If you are a citrus farmer, person on a diet, or plumber, that word may scare you. If you're anyone else, feel free to listen. This is a family-friendly program. Scale. So there's two issues of scale I'd like to talk about. One has to do with why we're working in the field. The second has to do with, backpacking kind of thing. I'll do that one first. One of the things that always strikes me when we're backpacking is starting out at 8 a.m. hiking for 8 hours and then looking back at a map and looking at the terrain from a high pass and seeing where you've gone. And, you're really impressed with how far you've gone in such little time or whatever. How much elevation change you've made, how many miles you've crossed. A lot of times how much farther and faster you've gone than other people. When you see them on the trail and you tell them where they're coming from, they're like, no, really? Or, you see somebody down by Forester Pass and they ask where you came from and you say Onion Valley and they say, not today. You say, yes, today, and they say, no way. Anyway, scale. Then you get to the car on your hike out and you start driving.
Here in my car, I feel safest of all. I can lock on my doors.
And at first, I always have trouble going fast. Getting up over 35 is a little scary. Hitting 65, I don't know, I just can't do it. But eventually you get there, and you're driving up Route 395 back to Mammoth, and you look over your shoulder and you're like, oh crap, I've been driving for 30 minutes and I've already passed the trailhead I started at 7 days ago. And it's always a little bit shocking, a little bit sobering about how much cars can do for us and how much we rely on them for quick transit, but also how rewarding it is when we don't rely on them and we just walk. And you can see how far you can get and how long it takes you and how good it makes you feel, how hungry you are. Okay, so the second part of scale is a scientific question. And it's one that ecologists have dealt with since there were ecologists. And really, there have only been a lot of ecologists for, half a century or so. But we've always dealt with the issue of scale. What do I mean by scale? You can look at things at different scales. You can look at the way organisms interact at the individual to individual scale, within populations, within communities, with other species, within metapopulations, with other habitats, other populations, or within a whole ecosystem with physical, chemical, biological processes going on. And whichever scale you choose to look at determines, to some extent, how you're going to do your science. My question really deals with communities, and to some extent, ecosystems. And what we want to know is, if you remove one species, what happens to the other species? What happens to the biological interactions? And something we've been getting into more lately, what happens to some of the relationships between organisms and the nutrients in the lakes? Well, you can't do this in a lab. It's really hard to build artificial communities. It's really hard to do competition experiments. It's hard to, despite diversity in these lakes being relatively low for insects and vertebrates, it's still really hard to do experiments on them because you can't isolate them all and you can't test who interacts with who and which species does which because there's just too many relationships. So you go out and you study the whole community at once. And you take some aggregate measures, you collect a lot of individuals and you identify them to species. And then you come up with a number. And that number means something like diversity or species richness. Then you compare it to some variable of choice. In our case, that variable is whether there are frogs here or not. Whether frog populations in a lake have changed over time. So we compare this, one number that we picked out, diversity or whatever, frog status. A ton of really good ecology has been done in labs or in field experiments where enclosures or exclosures are used and various interactions are examined between individuals or species. And a lot of what we know about ecology comes from that kind of work. That some of those effects that we see in those enclosures or in those cages or in those lab experiments, we don't see in nature. And that is an issue of scale. So in nature, you have all these other things going on. Let's, for example, say you're trying to test whether a tadpole can suppress the growth of algae and can control the population size of algae in a lake. Well, you could do this in an experiment, and it's been done. And a lot of times we find that tadpoles can eat all the algae and suppress algal growth. Okay, but here's where scale comes in. Because even though we know that tadpoles can control algal growth, out here in a lake, we don't necessarily see that. You've got a huge lake. It's a hectare. It's 20 meters deep. That's a lot of surface area for tadpoles to be grazing on. In addition, there's also all these other inputs influencing algal growth. Temperature, nutrients, daylight are not the same throughout a lake or between different lakes. So when we measure these things in a lake, algal growth, number of tadpoles, and we try to compare them between lakes or within a lake, it's really difficult to see an effect unless that effect of tadpoles is huge. And they just have such a huge effect on the algal growth in a lake. Even in lakes where we see 16,000 tadpoles, or estimate that there are 16,000 tadpoles there, which is just a ton of tadpole biomass, and lots of little sucky little mouths scouring the rocks, and 30 centimeter long guts processing algae and pooping it back out. It's really hard to see an effect because tadpoles are moving around, they're grazing in different places, they like some places more than others, and algae like some places more than others, and any various spot that you sample may or may not be a spot that algae like and that tadpoles like, or vice versa. And so when you're working at this whole lake scale, it can be very difficult to see that effect that you found in your experiment. So one of the points I'm trying to make about scale relates to why we're out here and what we're trying to do. We can see effects in experiments that we may not see in lakes. Why does that matter? Well, okay, so you are working at this small scale. Can you actually extrapolate to the big scale? Can you extrapolate to the whole lake scale? If you see this effect of tadpoles at the experimental scale, are you guaranteed that that actually happens in nature? Well, I would prefer to, personally, and not everyone needs to do this or wants to do this, I would like to find out whether we're going to be able to observe changes in whole lake communities. Whether the changes in tadpole populations that we're going to see with chytrid-caused declines are actually significant, and if they're actually going to change the lakes. Just because we see it in the experiment does not necessarily mean that we're going to see it in a lake in the Sierra Nevada at 11,000 feet. Even if it went from having 16,000 tadpoles one summer to having 2,000 the next summer and 0 the following summer. We might not see that effect. And that really, to me, is where the result is. Not in what we saw in an experiment, but in what actually happened in nature. And that's why I've chosen to work at this scale. To spend all these miles hiking, all these days in cloudy, cold, windy conditions, to be out here at all these dozens of lakes where we can actually observe what's happening as these frogs go extinct. I hope this helps to explain a little bit of what I'm doing out here and why I'm doing it and where I think I fit in to the grand scheme of ecology and science. Thanks for listening. Have a great night.